we introduced our portfolio risk and our portfolio return equations. We showed that if there is no diversification, when the correlation coefficient, or rho, equals 1, then we're at our highest risk. If there is some diversification, which means that rho, or the correlation coefficient, is less than 1, then there is less risk, and so we showed that diversification lowers risk. That was a bit of an aside. Now we're going to move on. Remember, we started with two assets. We could put 100% of our money in one, or we could put 100% of our money in the other. And we showed that either through dominance or higher utility, we could figure out which of these two assets to put all of our money in. Next, instead of looking at two risky assets, we said, well, let's consider one risky asset and a risk-free asset, try to figure out which is better, and then we maximized utility. Now we're going to expand our investment opportunity set into our first real portfolio. And we're going to continue on with one risky asset and one risk-free asset, or the risk-free asset, but we're going to allow any allocation between these. So you can have all your money in the risky and none in the risk-free, or 99 in the risky and 1 in the risk-free, or 98 and 2, and so on, so that any allocation is possible between the risky and the risk-free asset. We're going to have a special name for this two-asset portfolio, where one is the risky and one is the risk-free. And we're going to call this the combined portfolio. And I'm using the terminology that's in the textbook. So the combined portfolio is a combination of the risk-free asset and a risky asset. They are combined together. Now we're going to skip a step in this process. Usually we would think about the risky asset in the combined portfolio as a single stock, but instead we're going to skip a step and let's think of this risky asset as an investment in a risky portfolio. And it might be useful to think about this as the market portfolio. And so going forward for this next little bit, we can think about our investment choice as the risk-free asset, think a money market mutual fund, and a risky portfolio, maybe the market portfolio, maybe the S&P 500 and an ETF and the S&P 500, the spiders. And we'll come back and spend a lot more time on ETFs later in the semester. But this is just an easy way to invest in the entire market portfolio. And we'll combine these two assets to form the combined portfolio C. It's going to be a risky portfolio P, totally defined by the expected return of the portfolio and the standard deviation of the portfolio, and a risk-free asset totally defined by F. Now later on, when we talk about portfolios of risky assets, we're going to use the W's, W1, W2, W3, W4, to define the weights of the risky assets that go into this portfolio P. And so to avoid confusion, when we're talking about the weights of assets in C, in the combined portfolio, we're going to use Y. And so we'll use special notation when describing the weights of P and the risk-free in the combined portfolio. And so only in the combined portfolio C, the weight of the risky asset P is Y, and therefore 1 minus Y is the weight of the risk-free asset in the combined portfolio C. So just again to review, and we'll see this on formula sheets, and we'll see this a lot throughout the semester. We use Y for the weights in C. We use W's for the weights in P. So we're going to plug these into our portfolio return and portfolio risk formulas. And so since P is essentially asset 1, we're going to swap out, instead of having W1, we're going to have Y. And since RF is essentially asset 2, we'll have 1 minus Y instead of W2. And so the expected return of our combined portfolio is the weight of the first asset times its return, plus the weight of the second asset, which is 1 minus Y, times its return. And because we have Y on both sides, I can distribute the RF through, and I get an RF minus a Y RF, and I can combine these, and I get that the expected return of the combined portfolio is the risk-free plus Y times the expected return of P minus the RF. And I know this looks like the capital asset pricing model. It's not really that. It's a very similar form, but this is the expected return of the combined portfolio as a function of the risky asset and the risk-free asset. The risk of this combined portfolio is a little tricky to start, but gets a little bit easier. Since the combined portfolio contains the risk-free asset, a number of values in the portfolio risk equation will equal 0. For example, the risk of the risk-free asset is 0, and the correlation of the risk-free asset and the risky asset is 0. Since there is no risk, since there is no change in the risk-free, it has 0 correlation. And so I plug in, instead of W1 I use Y, and instead of W2 I use 1 minus Y. And so I plug everything into my equation here, but I realize that this value, and this value are all 0, so everything drops out and I get Y squared, sigma P squared, take the square root, and this is what I get. And so now I have these two highlighted formulas where I have the expected return of my combined portfolio is equal to RF plus Y times the risk premium for the risky portfolio. And the risk of the risky portfolio is just the weight, the risk of the combined portfolio is just the weight of the risky portfolio. And so what I want to do is I want to combine these two highlighted equations. And what I want to do is I want to put them together so that we have something that we can maybe find is a little bit more useful. What I want to do is I want to get rid of the Y essentially. I want to put them together so that we can, in this particular case, choose the risk of the combined portfolio on the right-hand side. I'm going to choose the risk to get the return of the combined portfolio on the left-hand side. And the reason I'm doing it this way is because this is how we're graphing it. I have this on my x-axis, and I have this on my y-axis. And so I want to see what happens when I choose risk and get return. So I'm going to rearrange the risk of the combined portfolio, and then I'm going to substitute in. So I'm going to take my sigma c equal to y sigma p, and I'm going to solve for y. And I have y right here, so I'm just going to substitute through. And then I'm going to rearrange it slightly so that I have what I'm choosing, sigma c, as a function of my investment universe. And remember, my investment universe is defined by the risky asset, expected return of P and sigma P, and the risk-free rate. Now let's look at this green term. The green term is the Sharpe ratio of the risky portfolio. It's also the slope of a line that connects the risk-free and the risky. This line depicts all the possible asset allocations between the risky and the risk-free. It's therefore called the capital allocation line. It's also the slope of this line. So here's how I want to think about this. If it is the case that I can invest either in the risk-free or in the risky or any combination of these, it's not going to be a big curvy line this way or a big curvy line this way or a big curvy line this way. Because of this equation, I can demonstrate that the allocations that are possible between the risk-free and some risky must be a straight line. And here are some numbers that I've plugged in. I've assumed that the risk-free rate is 3%, that the return on the risky asset is 10%, and its risk is 20%. And I can see the slope of this line is 0.10 minus 0.03, that's the rise, divided by the run, which is 0.2, and I get 0.35. And the way to interpret that is that for any increase in risk of 1%, I'm going to earn 0.35% more in return. This is what is possible in my investments universe. Now, here's the point. All of the spots on this line are achievable given our investment rules. The question is, how do I decide where I want to be? How do I decide if I want to be here? How do I decide if I want to be here or somewhere in the middle? And that's what we're going to do next.